Assalamualaikum warahmatullahi wabarakatuh. My name is M. Jabar Alvansena, 1906-356-336 from numerical method number 1. Uh, I'm from assistance group number 1 with Bang Rijal Godi as the assistants. Here I am with Irfan Nafis as my teammate. We're gonna explaining about our latest assignment, that is the finite element method of 2D truss analysis using Open Modelica. So let's take a step back first. We overview about the linear algebra. So linear algebra is a system of equations can be represented as a product of matrices or as an augmented matrix. It is one of the example is a x equals to b. There are also special types of square matrices with unique properties. So in the down here, we have product of matrices and the augmented matrix. We can see the difference. So how about the methods of solving the linear algebra in this chapter? We have the direct methods and the indirect methods. We use direct methods when it is a small field matrices. The example of the direct methods is Gauss elimination method and Gauss Jordan method. When we use the indirect or iterative methods, we use the indirect methods when the matrices is quite large and it's a sparse matrix. It means that the matrix contains many zero. So one of the example of the indirect method is Jacobi method and the Gauss-Seidel method. So let's jump into our exercise. Here we choose, me and Irfan Nafis choose the number 5 as our assignment. Let's read the problem first. The members of the truss shown in the accompanying figure have a cross-sectional area of 20 centimeter quadrat and are made of aluminum alloy with elasticity equals to 70 gigapascal. So here we have the truss image. Wait, let me see. Can I annotate? Yeah. Let me annotate here. We have node 1, we have node 2, node 3, and node 4. We have 4 nodes with the length from node 1 to node 2 is 1.5 meter. Node 2 to node 4 is 1.1 meter. The length of node 3 to 4 is equals to as the long of node 1 to node 2, and we have forces here which is 10,000 Newton. The boundary we can see here at node 1 and node 3. So that is the problem of our assignment. Let's jump to the next slide. So our first step in solving this problem using Open Modelica is we first setting up the parameter that we're gonna use, such as point, trusses, and boundary, using k equals to a times a per length, or L means that L length of the truss. So we made a table here, which is truss 1 is node 1 to 2, truss 2, node 2 and 3, truss 3, node 3 and 4, truss 4, and the node is 2 and 4. So we can assuming from the previous slide that the truss 1 is here. Wait, let me annotate. The truss 1 is here. The truss 2 is here. The truss 3 is here. And the truss 4 is here. Okay. Let's jump into the next slide. So from the problem, we know that the area, cross-sectional area of the truss is 20 centimeter quadrat, and we convert it to meter quadrat, which is 2 times 10 to the power of -3. And then we have the elasticity of the aluminum alloy, which is 70 gigapascal, and we convert it to Newton per meter, which is 7 times 10 to the power of 10 Newton per meter. And we state the number of trusses is 4, as we know from the problem. So what is this problem we want to solve? We are looking for the displacement and also the reaction force from this problem, from these trusses. Okay, so how do we find the displacement and the reaction force? Me and Irfan Nafis here has already setting up the OpenModelica code to solve these problems. That we first here we gonna define the problem first in this section, such as here we have the define initial variable. Initial variable means that it is points, number of points. We have 4 points. Yeah, points 1, points 2, points 3, points 4. We can call node as points 2. So in line 5, we can state the number of trusses, which is 4, as we know before. And in line 6, we state the cross-sectional area of the trusses, which is 2 times 2 to the power 2 times 10 to the power of -3 meter quadrat, and the elasticity of the aluminum alloy, which is 70 gigapascal. So let's jump to the next line. It's define connection. In define connection, we here state the integer c. C means that connection. We put trusses, comma 2 here. 2 means that in each line we have 2 parameter, 1 and 2, 1 and 2, 1 and 2. Yeah, that's the connection means that we have connection between node 1 and node 2. We have connection between node 2 and 3, 3 and 4, and so on. In line 15, we read that define coordinates. So we define the length of the node. Actually, we define length of the trusses. So here we put it orderly, similarly to the integer connection in connection here. So at trusses 1, which is node 1 to 2, the node position is 0.0, and node 2 is 1.5, 0, and node 3 we have coordinate 0 here. I mean this coordinate is per sesuai dengan jaraknya dari terhadap sumbu x, dan 0 x dan 0 itu dianggap di sebelah kiri. And so we have these coordinates 1.5, 0, 0.1, 0,1, 1.5, 1, so on. So in line 21, we can define the external force. As we see here, we have external force in node 4 equals to 10,000 Newton. So here we create parameter F, points times 2. So we have the force here 0.0 because of the force is only at node 4. We put it on the node 4 only, and we have it negative because it's point downwards. And then the next is we define the boundary of this problem. As we see, the boundary is on the node 1 and the node 3. So we put it node 1 and node 3. Okay, wait a minute. Okay, let's jump to the next slide.